In this video, we are going to go over section 3.7, elasticity of demand. The goal of this section is to determine the elasticity of the demand for the function. Such questions should be asked when you're thinking about the elasticity of demand, like when will a price increase lead to an increase in revenue? To answer this question and study relationship among price, demand, and revenue, economists use the notion of elasticities of demand. In this section, we will define the concept of relative rate of change, percent rate of change, and elasticity of demand. So let's take a look at the following definition. So the relative rate of change function is given as f prime of x divided by f of x. Percent rate of change is here we have a relative rate of change, and then if you want to get generally percentage, we multiply by 100. So whatever relative rate of change, if you want to get percent, we will multiply by 100 to get the percentage. Now we have a theorem, elasticity of demand. Economists use the concept of elasticity of demand to answer the question, when does an increase in price lead to an increase in revenue? So if a price and demand are related by a function x, which is equal to f of p, then the elasticity of the demand is given by E sub p equal to negative p f prime of p divided by f of p. Kind of similar to very similar to relative rate of change, except we have a p and then the function is written as f of p, not f of x. If E sub p value is between 0 to 1, then demand is inelastic. If E is exactly 1, the demand is the unit. If E sub p value is greater than 1, then demand is elastic. So what does it mean when demand is inelastic, elastic, and unit? Inelastic means, interpretation for inelastic means demand is not sensitive to the change in price. That is, percent change in price produces a smaller percentage change in demand. Therefore, revenue, in terms of revenue, a price increase will increase the revenue. If price and demand is elastic, that means demand is sensitive to the change in price. That is, percentage change in price produce larger percentage change in demand. That means in terms of revenue, a price increase will decrease the revenue because demand is sensitive to the change. Unit means a percentage change in price produce the same percent change in demand. So let's practice couple rounds and then end with couple application problem. So very first one, use the given equation which expresses price P as a function of demand X to find the function f of P that expresses demand X as a function of price P. And we identify the domain of f of P. So take a look at this. We are given P function. We need to come up with f of P, which is X equal to f of P function right over here. This will be eventually needed when we take, this is what we are doing, okay? Writing the P function as X function. And then eventually these functions will be used to find the E sub p. So let's do a warm-up problem, practicing just coming up with x equal to f of p. So that means I need to have x by itself because I want to solve for x. Right now you have p, but I want to have x by itself. So let's take this equation and solve for x. So we have p equal to 54 minus 0.5x squared minus 54 each side. So we have a p minus 54 equal to negative 0.5 x squared. Then we would divide it by negative 0.5. So I have negative p over negative 0.5. This two negative makes a positive. 54 over 0.5 equals x squared. Now, this is same thing as, oops, I don't know why I put negative p. Should be positive p because it's positive here. Now, negative half on the bottom will make a negative 2p. 54 divided by half is positive 108 x squared. In order to have x by itself, I would square root each side. So x is equal to negative 2p plus 108. In other words, you can rearrange x is equal to 108 minus 2p. Now, this is a function. This is exactly what we found. We found the x written in terms of p, f of p. So this right over here is the answer, and that is my f of p function. Okay. Now, we also have to find the domain. That means our p value, because our input is p. Here we are given x value. So we can you can plug it in these x domain into our function and then find where the p is between. So I'm going to plug it in 0 and then square root of 108 and then find out our domain for p. So let's start with the 0. So if I plug it in 0 for x, because that's what the x is defined, then I have 0 is equal to 108 minus 2p. Let's solve for p so we can find the domain of p. So I would square each side to get rid of square root. So 108 minus 2p minus 108 minus 108. Negative 108 equals negative 2p divided by negative 2. P is equal to 54. So that's one of them. We also have x as a square root of 108. So let's also plug it in. X is square root of 108 equal to square root of 108 minus 2p. Again, where am I getting zeros and 108? Right over here. X is defined from 0 to 108. To have p by itself, I would square both sides to get rid of square root. So 108 is equal to 108 minus 2p. Subtract 108. So I have 0 equals negative 2p. Divided by negative 2, so p is equal to 0. That means domain of f of p is p has to be between 0 to 54. Okay. So first example, we practice how to write a function p in terms of f of p, in terms of x, which is written as f of p. Okay. All right, now let's take a look at some other problems. So number 2 is asking you to find relative rate of change. Here, relative rate of change is given as f prime of x divided by f of x. So that's simple, just very simple formula. So that's all we have to do. So number 2, my f of x, here you can see that it's 7x squared minus 2ln x. Let's take f prime of x, which is 14x minus ln x is 1 over x multiplied by 2. I have 2 over x. Relative rate of change formula is here f prime of x divided by f of x. So plug it in. 14x minus 2 over x divided by 7x squared minus 2 ln x. Done. Okay. Number 3 is very similar. We will find the relative rate of change, except we are going to, we are given specific x values. So we will do substituting. Okay. So let's do one more. So that means f of x is 500 minus 9x. F prime of x will be, well, 500 is just 0 constant, so 9x is negative 9. Now, we are going to take extra step because x is given. Let's plug it in. So f of 60 is 500 minus 9 times 60, which is equal to, I got negative 40. Now let's find out f prime of 60, that's just negative 9, constant function. Therefore, relative rate of change, which is when x equals 60, is f prime of 60 over f of 60. So I get negative 9 over negative 40. In decimal, that will be 0.225. Okay, very simple and easy. Let's take a look at number 4. Given f of x is equal to 4,000 minus 6x squared, find percentage rate of change when x equals 30. This is percentage rate of change. So that is f prime of, well, 30, because we are given x value. And then we are going to multiply by 100 to make a percent. That's what we have it over here. You can, of course, rearrange because it's a commutative. Multiplication is commutative. So f prime of x divided by f of x times 100. So let's find out. Let's f of x is 4,000 minus 6x squared. And then f prime of x, that's constant. And then second one is negative 12x. Let's go ahead and then do substitute our 30 into both function. So 4,000 minus 6 times 30 squared. Putting that into a calculator, I'm getting final answer 1,300. Right over here, negative 12 times 30 will give me negative 360. Let me erase this part so we have more space. So percent rate of change is f prime of right over here. Let me in fact just copy right over here, plug it in. Right? So my top function is 1,300, negative 360. My bottom function is 1,300 multiplied by 100, so negative 360 divided by 1,300 times 100. I'm getting final answer as 27.7%. Don't forget our unit percent because that's what we found. 27.7%. All right, we have 5 and 6, okay? And then number 7, which is 6 and 7 is a little bit of an application problem. Now we are going to move on to elasticity. So it's this one over here, theorem 1. Elasticity demands is given as right over here. E sub p is equal to negative p f prime of p over f of p. And we practice how to write x function as f of p. So number 5, we are given already the x function in terms of p. That's good. X is equal to fp. Use the price demand equation to find E sub p. So that's easy. You have the equation. E sub p is written as, right over here, I'll just copy negative p f prime of p divided by f of p. Negative p f prime of p divided by f of p. Now we have f of p already over here. So f of p, let me put it right over here. So f of p is already given as 10,000 minus 350p. So f prime of p will be derivative of 10,000 is a 0, 0. Derivative of negative 350p will be negative 350. So plug it in. Let's plug it in into this equation. We wanna find out is a p. So negative p times f of p, which is negative 350, divided by f of p, which is 10,000 minus 350p. Let's keep going. The two negative makes positive, so I have 350p over 10,000 minus 350. Okay. I can divide each by 50. So everything is divisible by 50. So 50 goes into 350 7 times. 10,200 7 times. So my final answer at the end will be 7p over 200 minus 7p. That's your E sub p. Okay. E sub p is equal to 7p. This is an equation of elasticity of the demand function. Okay. Number 6, very similar. We are given again our f of p. Use the price demand equation to find E sub p, the elasticity of demand. That's what we did all the way up to here. So first part is exactly same thing as number 5. You want to find the E sub p. Then we are given the value p, 15, and we are going to determine if our value of p is elastic, inelastic, or the unit elasticity. Okay, so let's first find out E sub p. E sub p is given as negative p f prime of p divided by f of p. F of p, as given right over here, is 850 minus 3p minus 0.04p squared. So f prime of p is constant, negative 3. And then the last one, you bring down the power and then subtract by 1. So that will be negative 0.08p. Okay. So let's plug it in. So E sub p is negative p times f prime of p, negative 3 minus 0.08p, divided by 850 minus 3p minus 0.04p squared. Let's keep going, and then let's keep going. So this will be distributing positive 3p, positive 0.08p squared, and then the bottom is nothing to combine, so stays the same. That's your E sub p. So that's the first part. We found the E sub p. So that's first part. Next, let's use the value given, which is p equal 15, and see if to determine whether the demand is elastic, inelastic, or the unit. So plug it in 15 for p. 3 times 15 plus 0.08, 15 square divided by 850 minus 3p, but 3p is equal to 15 minus 0.04, 15 square. So the numerator, I get 63. Denominator, putting everything into calculator, I get 796. So let's get that into a decimal number. I get 0.079. What is a 0.079 means? That's a number between 0 to 1, right? Bigger than 0 but less than 1. So what is that? That's a case 1, inelastic. So demand is inelastic. Okay. Demand is inelastic. Furthermore, this can be interpreted as the following here, right? So I'll write it down in words. Demand is not sensitive to change in price. That is percentage change in price produces a smaller percentage change in demand. Okay. All right. There, last question, and that's it for this section. This is very similar to number 6, except this time we do same thing. We are given x equal to f of p function, and then we are going to find the p where demand is elastic. And the values for that is inelastic. So this time they're not given a p-value and we check. This time I have to find the p-value where this function has elastic value and inelastic. Okay, so let's first find out elastic functions. So that is E sub p is equal to negative p f prime of p divided by f of p. F of p is given as 900 minus 3p squared. So f prime of p, constant, so 0, negative 6p. So plug it into the formula. We have negative p times negative 6p divided by 900 minus 3p squared. So my elasticity function is 6p squared divided by 900 minus 3p squared. Now looking at the coefficient, everything is divisible by 3. 3 goes into 6 2 times, 3 goes here 300 times. 3 goes here just once. So E sub p can be rewritten as 2p squared divided by 300 minus p squared. So that's the first part. But that's not it. We wanna find where the demand is elastic. Let's begin with elastic. So for demand to be elastic, that means E sub p has to be elastic, means greater than 1. Greater than 1. So I'm going to set this function here and then set it equal to greater than 1. So E sub p, I have it right over here. 2p squared divided by 300 minus p squared, and then set it greater than 1. And so for p, that's what I'm trying to find. Find the p value when it's elastic. So I'm going to multiply each side by 300 minus p squared so that my denominator gets disappear. 2p squared means distributing 300 minus p squared. Let's combine all the p's. So p squared, p squared. So I have 3p squared equals 300 divided by 3. P squared is 100. To have p by itself, I would square root. So p has to be greater than 10. Okay. All right. So any value greater than p greater than 100, p greater than 10, we have an elastic function. So p greater than 10, the function, let's write a sentence. So this means demand is elastic when p value is greater than 10. Now for inelastic, we are going to set E sub p between 0 to 1. That's when demand is inelastic. And let's find out our p value. So for demand to be inelastic, we are going to have E sub p set it between 0 to 1. So E sub p from previous, right over here, we have it here. 2p squared divided by 300 minus p squared. So 2p squared divided by 300 minus p squared between 0 to 1. Okay. So let's work both sides. You can separate it or work both of them at the same time. So multiply the whole inequality over 300 minus p squared. So that means here, here, and here. So 0 times anything is a 0. Okay. And then we have 2p squared minus 300 minus p squared. Okay. So add p squared. 0 is 3p squared, and then less than 300 divided by 3. I get 0 less than p squared equals 100. So I'm going to have square root entire side. P is between 0 to 10. So anything greater than p greater than 10 we get elastic. Any p-value between 0 to 10, we get inelastic. Okay? Very simple. Concept of relative change, percent of change, and elasticity for this section. Okay, that's it for chapter 3. On the next video, we are going to go over chapter 4.